Module 4, Multiple Axis Rotation. In this video, I'm going to talk about rotation about more than one axis. I'll talk specifically about rotation about two axes, but you can apply this to even more than two axial rotations. I'll talk about the order of rotation and how that's important, and then I'll also offer some equivalent rotations similar to single axis equivalent rotations. In multiple axis rotations, each subsequent rotation is based off of the previous object and not the original object. Now, your first rotation is going to be based on the original object, but your second rotation is going to be based on the isometric of the first rotation and not the original object. So suppose you have an object like the one shown below. The arrow coding specifies a positive 90-degree rotation about the x-axis, followed by a positive 90-degree rotation about the y-axis. So the first thing we would have to do is rotate this original object positive 90 degrees about the x-axis. The resulting object would look like this. Now, the next rotation is applied to that first rotation, so the positive 90-degree rotation about the y-axis would then look like this. So that final isometric is what the original object looks like when it's rotated positive 90 degrees about the x-axis and then positive 90 degrees about the y-axis. Order of rotation is important. The final isometric will look different if you reverse the order of rotation. So suppose you have an original object like the one shown here. If you're to rotate that object positive 90 degrees about the x-axis and then positive 90 degrees about the z-axis, you'll notice that your resulting isometric is different than if you rotate the object positive 90 degrees about the z-axis and then positive 90 degrees about the x-axis. And this tells you that positive 90 about x and then positive 90 about z is not the same as positive 90 about z and then positive 90 about x. So it's important for you to be consistent with the order of rotation that's given to you and perform the operations in the order that's specified. Similar to single axis rotations, equivalent rotations also exist when dealing with multiple axes. Now, some of these may not always be immediately obvious, but they can be used to really simplify some very complicated axis rotation sequences. So here's an example. If you have this original object that's shown on the left, and you rotate it positive 90 degrees about x and then positive 90 degrees about z, your resulting object is the same as if you were to take that object and rotate it positive 90 degrees about z and then positive 90 degrees about y. This is an example of an equivalent rotation when you're working with multiple axes. And even though in this case the amount of work would be roughly the same, I just wanted to show that equivalent rotations do exist and can be used to break down very complicated sequences of rotations. So let's look at some examples on how to perform multiple axis rotations by starting with a coded plan, and we're going to take that coded plan and draw the isometric, and then we're going to rotate that isometric based on the arrow coding provided to us.